In question 7, we're told the triangle XYZ in figure 1 has XY equal to 6 centimetres, YZ equal to 9 centimetres, ZX equal to 4 centimetres, and angle ZXY equal to alpha. The point W lies on the line XY. The circular arc ZW in figure 1 is a major arc of a circle with centre X and radius 4 centimetres. In part A, we need to show that to three significant figures. Alpha is 2.22 radians. So there's alpha right there, and we can use the cosine rule. So what we're going to say then is alpha will be equal to the inverse cosine of, and we will take 4 squared plus 6 squared minus 9 squared. So 4 squared plus 6 squared minus 9 squared, all over now 2 times by 4 times by 6. So 2 times by 4 times by 6, and then we'll just evaluate this on a calculator. So check it in radians mode, shift mode 4, and the inverse cosine now of 16, that's 4 squared plus 6 squared minus now 9 squared, and put that all over 48. And what does that give me? 2.2195, so we can say alpha is equal to 2.2195 and so on. So we can say alpha is equal to 2.22, and that's going to be now to three significant figures as required. So that's done. Okay, we need to find the area in centimetres squared of the major sector now. XZWX. XZWX. Okay, so let's do that then. So what we can say then is the area is going to be 1/2 r squared theta. So what I'm going to have now then is the area will be 1/2, then we'll have now 4 squared, and then we'll have theta. Now we're interested in this angle right here. So what I'm going to do is 2 pi minus my answer. So let's store this in the calculator, shift store A. So what I'm going to have then, now this is going to be, what's this going to be, squared, isn't it? 1/2 times by 4 squared. So we're going to have now, what's that going to be, 8. So we're going to have 8, and we'll put it in here. We're going to have 2 pi minus our 2.2195 and so on and so forth. So that will give me the area now of the major sector. So what have we got? We've got 8. Let's grab a calculator up. We've got 8, and then we've got now 2, and we'll have 2 pi minus my answer. And that's going to now give me 32.509. So we can say the area is 32.509 and so on. So we'll say now that this is going to be 32.5, and that will be centimetres squared, and that now is to three significant figures. Okay, so that part's done. So we've been given now 3 marks to do that. We're told the region enclosed by the major arc ZW of the circle and the lines WY and YZ is shown shaded in figure 1. We need to calculate C, the area of the shaded region, for 3 marks, and D, the perimeter of ZWYZ of this shaded region. Okay, so let's consider what they're asking for now. They are asking for all of this right here. So what we're going to have then is the part that we've just worked out plus the triangle. So what I'm going to say then is the area of the triangle is going to be equal now to, and this will give us 1/2 AB sine alpha. So what we're going to have then, the triangle is going to be 1/2, then we're going to have 4 times by 6 times by the sine of now the 2.21 ... and so on and so forth in the calculator. I'm then going to add it to the value that we've just found for this major sector. So let's go ahead and store that in. We're going to come back to that. We'll store that as B. So what we're going to have here then is 12 lots of sine of A. I stored this in my calculator. 1/2 times 4 times 6 is 12, and then we got sine of A. So that's going to give me 9.56 and so on and so forth. So we can say that the triangle is going to be equal to 9.56, and so on and so forth. Therefore, what we're going to have then is now 9.56 plus now the 32.5 ... that I've got stored in here, and we can go ahead and find that. So let's go ahead and do that. So I'm going to add that now to B, which was stored in the calculator, 42.07, 42.07 ... and we can say this is 42.1 centimetres squared. So that part's done. Okay, we now need to find the perimeter of ZWYZ. So let's consider what that is. That now is round the outside. So we've got now Z, W, Y, Z, and I'll just quickly sketch this on. It's going to be now, let's grab that. We want a different one. Let's grab the red one. It's going to be this right here. So we want to come round here, and we want to come down here. We want to go round here, and we want to go down here. So we can see now that this part right here is going to be 2. We've got 2 and we've got 9. This part right here is going to be the 6 minus the 4, which is 2. Let's now consider this part right here. And this is the major arc. So what we can say then is that will be r theta. Okay, so we've now got, remember, we've got theta in the calculator, but essentially we've got alpha, which is 2 pi minus that. So what we're going to have then is 4 lots now of, and we're going to have 2 pi minus the 2.2195 dot 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 and so on. Then we're going to have plus 2 plus 9. So let's go ahead and work that out in the calculator. So what we're going to have, let's grab this out of the way. We've got now 4, then we've got 2, and we've got 2 lots of pi. Now minus this value that's still in the calculator, which is going to give me 16.25. So we've got 16.25 dot 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 plus 11. So let's go ahead, add 11 to this. So add 11 and then we'll round it. 27.25. So I'm going to say now that's 27.3. So 27.3, and that will be centimetres, and that's the 3 significant figures. If you want to just put that answer on, just show you're working, but the perimeter to now 3 significant figures is 27.3 centimetres.